Let's study the stress strain graph right now for ductile materials. So ductile materials, as we mentioned in the ductile video, is related to object that fractures after a great amount of plastic deformation under tensile stress. So we are going to place this ductile material under a tensile test in which we are going to stretch the object and observe the strain of the object. So we are going to sketch a graph of stress against strain for this ductile material, and the kind of test that we do is tensile test. We are not doing compression tests over here. Okay, so there's a lot more stages for ductile materials compared to brittle materials, so this video might be a bit long compared to the previous video. Okay, so let's start. We start from stage O to A. So stage O to A here actually happens similar to brittle materials, in which you have an object, a specimen, that has an original length of L0. Okay, this is the original length of the specimen, and what you do is you put it into a tensile test machine in which you are going to stretch this material or stretch this specimen from the two ends. So as you stretch, you're applying stress to the object experiences some kind of stress, and because of that the object will experience some kind of extension, and the extension can be used to quantify the value called strain. Okay, so from O to A, you are in the region of elastic deformation. So any kind of change of shape, any kind of increase in length that happens now is reversible. Once you release the stress, the strain will get back to zero. So this is the same as what we discussed in brittle materials. You undergo elastic deformation. Object can return to its original length when the stress is removed. Your stress gets back to zero, your strain will also get back to zero. Nothing happens permanently. Okay? The stress is again directly proportional to the strain, so Hooke's law is obeyed. We mentioned this in the brittle video. Then next, the gradient can be used to calculate the gradient is known as the Young's modulus. Okay, so this is the same formula as what we have discussed in the stress strain graph for brittle materials. So once you have reached this point A in brittle material is the end of elastic deformation. At the end of elastic deformation, for brittle materials, what happens is there's no more plastic deformation after that. So the brittle material is supposed to fracture at this stage. But now we are talking about ductile material. Ductile material fractures only after you experience a great amount of plastic deformation. So that means that this is not the end for the ductile material. What happens is you have already reached a certain kind of limit, but that's not the end. It's just a limit that we known as the proportionality limit. Okay, this is the end of the journey in which the stress and strain are proportional to each other. After that, there's still much more to go, but this is the end in which stress and strain are being proportional to each other. After that, they will no longer be proportional to each other. That's the idea of proportionality limit. So here it's still elastic deformation, but at this stage the stress and strain for this elastic deformation is still proportional. Okay, so now let's continue. You are still in the elastic deformation region, but as you can notice, the end of the elastic deformation is not the same as point A. So means by there's a bit more journey to go until you reach the end of elastic deformation. Okay, so that's what's going to happen in stage AB. So for stage AB, what happened is elastic deformation still occur. Okay, it's same as stage OA just now. It's still elastic deformation. If you release the stress, the object can return to its original length. But what's different between OA and AB right now? AB, the stress is no longer proportional to the strain. Just now, OA is a straight linear line, so the stress is directly proportional to the strain. But now once you reach stage AB here, the stress is no longer proportional to the strain. So you observe that this is actually a slight curve over here. It's not a straight line, it's a slight curve because it's no longer linear. The stress is no longer proportional to the strain. So this is the difference between OA and AB. Okay, once we reach point B, okay, once you reach point B, we can say that you have already reached your elastic limit or U point. Okay, elastic limit, as the word literally say, you reach the limit of elastic deformation. As you can see, point B here is the end of the elastic deformation region. we already reached the limit in which you can undergo elastic deformation. This point indicates the limit of elastic behavior and the beginning of plastic behavior. So if you continue to apply stress, you enter the plastic deformation region. Any kind of extension that happens after that will be a permanent kind of extension or a permanent elongation. Okay, until stage B, if you release your stress, you still get back to zero strain. Okay, because all of them are elastic deformation. But once you go beyond this elastic limit or you go beyond this yield point, that's where plastic behavior happens. Plastic deformation will start to occur. Okay, we call the stress at this point is known as the yield strength. Okay, so if you reach this limit over here, that's the limit of elastic deformation. Then if you find the stress at this point, we call it as yield strength. Okay, yield strength is related to yield point. Okay, later I'll explain a bit further what is yield point, but basically you can think of yield point as the end of elastic deformation. Okay, the point where elastic deformation ends, the point where plastic deformation starts. We call it as yield point. And the stress at this yield point over here, we call it as yield strength. Okay, so that marks the end of elastic deformation. In the next video, we are going to continue with plastic deformation for ductile materials. Okay, so basically you stretch it, undergo elastic deformation, it gets longer, but there's still some more journey to go.